Welcome back to Chapter 6, Part 1, where we start learning how to solve systems of equations. And we are first going to solve a system of equations, where a system is where you have two equations, by graphing. So we are going to graph both of these equations. Well, when we graph both of these equations, we have to figure out what is our slope, and our slope here is 2, whatever is in front of the x, that's going to be our slope, and our y-intercept, and that is whatever is added or subtracted. So I'm going to go ahead and graph this line. So I go up 2 for my y-intercept, then from this point that I just put down, I'm going to go up 2 over 1 to the right to make it a positive slope. I'm going to draw one more dot, and now you go ahead and connect these dots with a line, as I do right there. And then next you graph the next line where your slope is -3, again whatever is being multiplied to your x, and your y-intercept is -3, so I go down -3, put a point. Now I want a -3 for a slope, but if I go up 3, I have to go over 1 to create a negative slope. So I plot one more point just so I can draw a straight line. So I go ahead and connect the dots. Now the lines intersect. Why do the lines intersect? The lines intersect because where they intersect is our solution, right? So our solution here, or actually they intersect at -1, 0, right? The x is -1, the y is 0, so our solution is going to be x is -1, y equals 0. Now you can write your solution as an ordered pair just like this, or you can write it x equals -1, y equals 0. Let's try the next one with number 2. Here we have x plus 2y equals 6. Now we do not have y by itself, so let's try and get y by itself as we subtract x from both sides. Then we bring down 2y equals -x plus 6. We have to get y by itself here, so y equals a -1/2 x plus 3 as we divide by 2. So we go up 3, put a point. Now its slope is a -1/2, so I'm going to go down. And now I want a negative slope, so I'm going to move to the right. I go down 1 again, put another point, just so I have 3 dots on my line, so I now connect the dots. Then with the next line, I again have to solve for y. So I go 6y equals -3x minus 12 because I subtracted that 3x. Now I divide by 6. I divide everything by 6 because I have to get y all by itself. So again, I have -1/2 x minus now 2. Now I go ahead and graph this line. Go down first, start with your y-intercept, graph your y-intercept, and then we go up 1, and we want a negative slope, so we have to go over to the left 2 because we want to create a negative slope. So now again, I'm going to graph this line. Now if we look at these two lines, will these lines ever touch? Will this line, the blue line and the red line, ever touch? No. So for number 2, there is no solution. Well, what kind of lines are these? These are two parallel lines. So for parallel lines, there is going to be no solution. You can write it out, or you can put a 0 with a slash through it. Or you may get the same line. When they're same lines, there is infinite solutions, or if you want to, the math way is a sideways 8, which is the infinity sign. Next couple. Now, besides graphing, that you can also use substitution. Well, when you use substitution, you are plugging in whatever your variable equals into your other equation. Now, if I use this red equation and I plug x minus 4 in for my y because y equals x minus 4. It's just like volleyball or football. Whatever you plug in, the other guy, what you plug it in for, has to come out. So I copy down my equation, 3x minus, and now instead of y, I'm going to write x minus 4, because that y now comes out of my equation because I subbed in x minus 4 in for y, so that equals 18. Once you do that, you just have to solve the equation. Be careful with that negative. Now it's 3x minus 4, or minus x plus 4 equals 18. Solve the equation. 2x plus 4 equals 18. 2x equals 14. X equals 7. Now that is 1/2. You solved 1/2 of the problem. Here we have x equals 7. We still don't know what y is, so we have to plug it in for our x to find y. So using y equals, and I'm going to use the red equation, x minus 4, I'm just plugging that 7 right in. So we have 7 minus 4 is 3. So now y equals 3. Let's try it again for 4. Now again, we're using substitution, but what if we do not have a variable that is solved for? Here we have x plus 3y equals 9. Here we have x plus 9, or sorry, x plus y equals 1. So we do not know what a variable is, so we have to solve for a variable. So I'm going to use this blue equation and solve for y. I just like solving for y, so I go y equals, and then I subtracted the x over, plus 1. Now I have an equation that I can use. I'm going to plug x, or negative x plus 1 in for that y, because that's what y equals. So again, I go x plus 3, and now I'm going to take it times negative x plus 1, because I'm plugging negative x plus 1 in for that y, so it's taking out the y and plugging in this. Again, just like you would sub in volleyball, softball, baseball, football, what comes in for it, the other guy has to go out. Now we solve this equation. So again, we distribute that 3, so it's x minus now, because it's times a negative x, so it's minus 3x plus 3 equals 9. Now we simplify, so it's negative 2x plus 3 equals 9. As we keep going, we have negative 2x equals 6, because we subtracted the 3. Divide by negative 2, so x equals negative 3. So again, that is one answer. Now how do we find y? Notice when I solve for y right here, let's go ahead and plug this negative 3 right there. So again, I have y equals negative, and then I'm putting in that negative 3 right here, plus 1. That is 3 plus 1, so y equals 4. So we have x equals negative 3 and 4 written as a coordinate point. It would look like negative 3 and 4. Let's try a couple more examples. Now we are going to use elimination to solve a system of equation. Elimination is you are getting rid of one variable through addition or subtraction. So we look at our two equations that we have. We have 3x minus 5y equals 11 and x plus 5y equals negative 3. The first thing we have to do when using elimination is to find the variables that have the same amount or the same coefficient, the number in front. So we look at our y's. We see that we have 5y for the top equation and 5y for the bottom equation. Awesome. So now we have to figure out, do we use addition or subtraction to get rid of the y's? Well, now I have a negative 5y and a positive 5y, so we have to add them. We have to add them to get rid of the y's, because negative 5y plus 5y is 0. So now that's going to be gone. So 3x plus x is 4x equals, bring everything else down, 8. Then we divide by 4, so x equals 2. So you found what x equals 2. That is our first part. Again, now it just is like substitution. What do you do with this x equals 2? You have to plug it in for a x. You can use the top or the bottom equation. I'm just going to use the bottom equation. You can use the top. You would find out the same answer. So here we go. We go 2 plus 5y equals negative 3, as I'm using the bottom equation. Solve for y. Subtract 2. Subtract 2. So now 5y equals negative 5. Divide by 5, so y equals negative 1. Here is my solution, so written as a coordinate point, it would be 2, negative 1. This is how we use elimination, so let's try just one more example. So next, again, we look at both of the equations. What equations have the same what variables have the same number in front of them? What variables have the same coefficient? Well, I look here. I see that we have both 2x's. Now, they are both positive 2x's. So now I have to use subtraction because I want to cancel out my x's. I want to make the x variable 0. So when I use subtraction, I am going to change all the bottom operations. So if it's a negative, it turns to positive. If it's a positive, it turns to negative. So now when I go ahead and combine my variables, I go 2x minus 2x, that is 0x, so I'm not going to write that down. Now I have 2y plus 8y, so it's 10y. It's just like you're adding a 3-digit number together. Then it's 4 plus 46, which is 50. So now solve for y equals 5. So that's the first part of my answer. Now what do you do with this y? Again, you plug it in. So let's try it, and I'm plugging it in for the bottom one. Now what was my original equation? My original equation was 2x minus 8y equals a negative 46. So let's see what we can solve, or what our x turns out to be. So we have 2x minus, again I'm putting in 5 for y. I take out the y, put in a 5. So now we have 2x minus 40 equals negative 46. 2x equals negative 6 because I added the 40 over. X equals negative 3. So now my answer, as written as a coordinate point, would be negative 3, 5. Well, let's say you didn't plug this in for the bottom one. What if you plugged it in for the top y? What would happen? Would anything change? So I'm going to use the top equation, which was 2x plus 2y equals 4. So I'm plugging in that 5 in for y. So I have 2x plus 2 times 5 equals 4. Simplify 2x plus 10 equals 4. I subtract the 10 over to get a negative 6, and x equals negative 3. Did I get the same x? Absolutely. If we got a different x, we would have done something wrong either in this equation or in this equation. But since we have the same x's, we know we did it right. You do not have to solve for both equations. You just have to make sure you get an x and a y. I just wanted to show you it does not matter what equation you would have put it in for. And that does it for Chapter 6, Part 1. Good day.